Good afternoon, everyone. Welcome to our naming ceremony for the Children's Cancer Fund Research Laboratory. My name is Edward Halperin. I'm the Chancellor and CEO of the college. I'm also a pediatric radiation oncologist, and thank you all for joining us, and thank you for the gift. What I want to talk with you about for a few moments this afternoon is this patient. If you can see my cursor, you can see that this is an pelvic MRI. There's the fifth lumbar vertebrae. There's the sacrum. There's contrast in the bladder. And you can see that the diagnostic radiologist has drawn a ruler of 16 centimeters from there to there. If you look at a coronal view, there's a lobulated mass in a different setting, a mass here. This is a 21-year-old who, when he was a teenager, was diagnosed with a malignancy of the prostate. Now, reaction would be, well, I know 80 and 90-year-olds with cancer of the prostate. Someone had a elevated PSA. Does it have anything to do with that? No, it has nothing to do with that. This is a sarcoma of the prostate, something called rhabdomyosarcoma. It is not prostate adenocarcinoma as occurs in adults. The patient, as a teenager, having been treated for a primary malignancy of the prostate with radiation and chemotherapy, now comes back with severe pelvic pain from a metastatic deposit enveloping the nerves emerging from the sacrum, and is referred for further treatment. This case raises some fundamental questions common to pediatric cancer care that I want to chat with you about for a few minutes this afternoon. In a scientific sense, why did the child get cancer? And in a scientific sense, what are we going to do about it? In a theological or philosophical sense, why did the child get cancer? And what are we going to do about it? Those are the four questions I want to grapple with you for a few minutes. What causes cancer? Well, when you teach medical students classic carcinogenesis theory, you tell them there are 5 basic causes. Some are spontaneous mutations. They just happen. Some forms of cancer are caused by chemical exposures, some by hormonal exposures, some by viruses, some by exposure to radiation. Viral causes, human papillomavirus and carcinoma of the head and neck or carcinoma of the cervix. Hormonal causes, uterine carcinoma, the fact that you can manage certain forms of prostate cancer or thyroid cancer with hormonal manipulation. The one that gets the most discussion is forms of chemical carcinogenesis in adults, which brings us to our first principle. Adults basically get cancer of places where their bodies meet the environment. Children almost always don't. That's the basic distinction. The classic and oft-cited study on this is called the Dahl and Pito study, after Richard Dahl and Pito, the authors listed there. The paper was published 45 years ago, but it is considered the definitive study, and almost any introductory oncology group will have a version of this pie chart that you can explain most cancers in adults from tobacco exposure, alcohol exposure, and dietary issues. They are more common in the poor and the Black and the marginalized of society, with one exception. melanoma, because repetitive sunburns and sun exposure is typically inversely correlated with poverty. It is a disease more often of the wealthy who go out and spend time at the beach in Punta del Este, whereas this is not an issue for the poor and the marginalized of society. Oh, the largest piece of the pie is tobacco. And if you look at common and particularly lethal forms of cancer in adults, it's overwhelmingly smoking. Industrial exposures in shipyard workers or home workers from asbestos, secondhand smoke, or radon gas from the earth in people who do not evacuate the radon gas from their homes or workplaces. You make cigarette smoking, both primary and secondhand, go away, and you don't see much adult lung cancer. You don't see it among Seventh-day Adventists. You don't see it among Latter-day Saints. You don't find it in Egyptian or Peruvian mummies. No smoking, very little lung cancer. For squamous cell carcinoma of the head and neck, instead of a pie chart, I show you a Venn diagram. In smokers, it's 18 times more common. In drinkers, it's 10 times more common. It's 28 times more common in betel nut chewers. You start combining these risk factors and you get to over 100-fold index. Betel nut chewing might be unfamiliar to some of you. This is a common habit in Southeast Asia, and with immigration in the United States is an increasingly common habit in certain places in the United States. Betel nuts are full of carcinogens. And so you combine that with smoking or drinking and you get this picture. But none of these are issues for children. Adults get places, cancer, where their bodies interact with the environment, but children don't smoke, don't drink, don't chew betel nuts, don't have unsafe sex practices. So you can eliminate all of those lists of causes and you're left mostly with spontaneous mutations. So why did the child get cancer? Mutations. What are we going to do about it? Well, from the standpoint of a pediatric radiation oncologist, we're going to irradiate to alleviate pain, ameliorate suffering, and try to get the young man onto a clinical trial for the next form of chemotherapy. But here comes the but. In this case, he had prior radiation, as you can see from this three-dimensional reconstruction. Particularly, I call your attention to the upper right corner where you see 3D images of the right hip, the left hip, prostate, the bladder. You see our beams coming from different directions. In an axial view, you see the radiation dose wrapping around the prostate. But I just showed you that the metastasis is here, so it partially overlaps where the original radiation was. And this raises the particular issue of why a lot of pediatric oncology is different from adult oncology. And if there was ever in the history of the oncology, the one picture is worth 1,000 words, it is a photograph taken by George Perthes. The pediatricians will recognize that sounds familiar, Legg-Perthes disease. But in 1903, he publishes in the German literature an experiment where he irradiates the left wing of chicks, but not the right wing, and lets the chicks grow up. And clearly growth is stunted by irradiation of chicks. And 40 years later, during World War II, an investigator named Hinkle starts irradiating the limbs of rat pups and shows that the femurs are obviously shorter on the irradiated side and deformed. So people like Dr. Cairo and I have to worry not only about curing the cancer, but curing the cancer with preservation of function. The effects on growth and development, this raises the stakes. So now we grapple with my two final questions. In a theological, philosophical sense, why does this teenager get cancer and what are we going to do about it? This is formalized by the Greek philosopher Epicurus. Now, some of you will know the term epicure, Epicurean, a gourmet. Epicurus is live a good life, have a good time, that's what matters. That's what he's mostly remembered for. What oncologists remember him for is something he calls the paradox. Put in modern terms, if there is an all-powerful, all-knowing, all-merciful, and all-just God, then why do children get cancer? Is God all just, all merciful, all knowing, but not all powerful? Is God all powerful, all just, all merciful, but not all knowing? He says it's a contradiction. Why should the innocent suffer? And this also shows up in the writings of Albert Camus. Remember the book, The Plague? Maybe they had you read it in high school literature class, and there's a character in Camus' novel, The Plague, Dr. Rieux, who, dealing with the plague, says, I refuse to believe in a God who permits the suffering of children. This is a restatement of the Epicurean paradox. So, you would think that in return for a steak and chicken lunch, I would now solve the paradox for you. That's what you're entitled to do. But I cannot. The book of Job is about it. People have spent enormous amounts of time writing about the so-called problem of evil, which brings us to why we're here this afternoon. Among the people who have grappled with this concept of why do the innocent suffer was a philosopher and theologian named Joseph Soloveitchik. Soloveitchik used to commute on the train from Boston to New York to teach in New York for generations. Soloveitchik leaves very few books. Most of what we have about his views are from his acolyte students copiously taking notes of everything he said and then reprinting them. And what does Soloveitchik have to say about this? He says, when faced with the problem of evil, of cancer in children, for example, you can cry out the why question and shout, why did this child become afflicted? And what response are you going to get when you cry out to the heavens? Silence. That's what's going to happen. Now you can try, there's a greater knowing beyond ourselves, or the minister puts their arm around your shoulder and says, well, it's really all for the good, we just don't understand. But that, Soloveitchik says, comes out hollow to me. He says, the only reasonable response to the problem of evil is action. That's the only thing a thinking person can do. You can spend all the time you want trying to earn tenure writing a thesis about the problem of evil. That'll maybe get you tenure, but it won't do any good and it won't comfort a suffering set of parents. So he says, do something about it. And that's why we're here. As when I was a young doctor and people would say, how can you get up in the morning and do what you do? I would say, well, I can't solve the problem of evil, and I'm not going to spend any more time doing so. I'm going to try to do something about it. And I submit that's why Mitchell or I or other people in our lines of work do get up in the morning, is whatever caused this cancer, we're going to do something about it. And that's why the Children's Cancer Fund is here, because we could talk about wringing our hands, but I would submit it's better to do something about it. So I thank the foundation for supporting this work. Thank you for your contributions, and thanks for joining us. And Ms. Pavocek, the podium is yours.
Thank you, everyone. Thank you all for coming here today. It's an honor to stand before you as president of the Children's Cancer Fund and to celebrate the naming of the official Children's Cancer Fund Research Laboratory. This moment is meaningful not only because the name now, the lab now carries our name, which I'm proud to have, but because it represents more than 3 decades of unwavering commitment to children and families facing cancer and blood diseases. For those of you who don't know, the Children's Cancer Fund was established in 1993 by a group of parents, volunteers, and hospital staff who saw children fighting and families facing unimaginable uncertainty. They knew something had to be done, and they didn't wait, they acted on it. One of those founding leaders, unfortunately, passed away this week. Andy Brenner helped build the Children's Cancer Fund from the very beginning. His vision, his generosity really helped shape the mission that we bring forward today. So I would like to honor his legacy for that. I also want to give a shout out to the board members that are here. We have Melissa Fiola, Claire McGuire, and where's Len? Len Mitchell, right back there. So thank you. Oh, hi, Janet. Uh, Thank you for all your hard work to really help move this process forward and to raise the funds that really are what we need to move this process forward. Sorry about that. Since its inception, I looked back before I got involved as well. CCF has raised over $10 million in support of pediatric cancer refund research. Much of that money has come here to New York Medical College and to the patients that we treat at Maria Ferrari Children's Hospital. And that research really fuels innovation, supports investigators, and moves promising science from ideas into real action. But what makes this really special is this partnership that we have had between Children's Cancer Fund and New York Medical College. We've worked side by side for more than 30 years, and it hasn't just been about philanthropy. It's been about trust, a shared vision, accountability, and a belief that children deserve better treatments, better outcomes, and better futures. This collaboration has stood the test of time. And today's naming is not a culmination, but it's a continuation of the work that we carry forward. Moments like this do not happen without generosity. Today's lab naming was made possible through the extraordinary support of our sponsors, who together, just for this event, raised over $70,000. I would especially like to thank our platinum sponsors at the $10,000 level, whose leadership and commitment to pediatric cancer research have made a lasting impact. The Alfano Family Charitable Foundation, Jeffrey and Bonnie Denkberg, Judy and Corey Cramen, and our very own Dr. Mitchell Cairo and his beautiful wife, Ellen, who deserves a medal for keeping him going all these years. We're also deeply grateful for our gold sponsors at the $5,000 level. Terry and Jeffrey Yagoda, who are here, Pete and Christine Monteleone, Leonard and Susie Buchan, Mr. and Mrs. John Deegan, Len and Dodette Schulman, and Robin and Keith Rosenthal. Thank you. This support fuels the science, it strengthens the partnership, and most importantly, it brings hope to children and families. And today, in addition to the money that was raised for the laboratory naming, Children's Cancer Fund is proud to continue our longstanding commitment to research taking place here at NYMC. So on behalf of our board, our donors, and the many families who believe in this work, it's my privilege to present Dr. Cairo with this ceremonial check. I never got to do this before, so I'm very proud of it. So actually, it's a little short because we got some late breaking donations in. So it's really over $360,000 that we've raised. So come on up. You can take that home with you. Okay, I want to quickly share a story that really reflects why this partnership and this laboratory matter. 10 years ago, an 8-year-old boy from the West Coast was diagnosed with a chemotherapy-resistant Burkitt lymphoma. His disease was aggressive and was not responding to standard therapy. As a nurse practitioner, I've sat with families at that exact moment when they are told that the therapy is not working. I've seen the fear in their eyes. I have answered questions at the bedside during the most difficult times, and those are the moments that really stay with you. His family was referred to Dr. Cairo and our team here, which is all here. We've got all our nurses over here. I don't want to leave them out, our research people, our lab, everybody coming together. So this young boy was referred here. They left their home, they left their other sons, their jobs, their support system, and flew across the country to Maria Ferrari so that they can be enrolled in a clinical trial that was created by Dr. Cairo and Dr. Hochberg. He received aggressive therapy to bring his disease under control. He had radiation, high-dose chemotherapy, autologous stem cell transplant, immunotherapy, Then he had an allogeneic stem cell transplant from an unrelated cord blood donor from the donor registry, which are stem cells donated at birth and preserved, waiting for a child somewhere in the world who might one day need them. A family you would never meet made the decision to donate that cord blood, and years later, that selfless act became his second chance at life. But his transplant was not the end of the fight. He required a prolonged stay in the peds ICU and in the hospital with liver failure due to complications from the chemo and radiation, which left him with less than a 10%, I'm sorry, 30%, I don't want to make it too bad, 30% chance of survival. There were moments when his family was preparing for the worst. And as a clinician, those moments are the ones that really test every ounce of your training, your teamwork, and your hope. But through innovative therapies, extraordinary multidisciplinary care, and relentless commitment, he survived. And after more than a year in New York, he was finally able to return home. That deserves a clap. 10 years later, that little boy has grown into a young man. He graduated high school and was preparing to return to the East Coast, not this time for cancer treatment, but this time to play baseball at Penn State, Greater Allegheny. He was getting ready to leave when he developed another life-threatening complication, a constriction of blood vessels affecting his liver and his spleen, which were late effects of the very treatment that saved his life. So instead of starting college, he underwent a series of complex and high-risk surgeries, another reminder that survival, while miraculous, is not always simple. The research cured his cancer, but his story reminds us that cure is not always the end of the journey. I'm happy to say that today he is doing well, and he's continuing to move forward with the goal that he will return to the East Coast to fulfill his dream of playing ball. And hopefully that will happen in the fall. And his coach held his spot for him. So that's a good story. So as a nurse practitioner, I celebrate remission, I celebrate survival, and I celebrate every child that gets to walk our red carpet, which we had a great red carpet today. Actually, you should have come. The red carpet, for those of you who don't know, when patients get a transplant or have prolonged hospitalization, we roll out a red carpet and everybody, the kids get to pick a song and everybody gets whistles and pom-poms and we applaud as they walk the red carpet out of the hospital, hopefully for the last time. But we can see that's not always the last time. So we see the long road that follows, the late effects, the organ damage, the PTSD, these challenges that can surface years later when the family just thinks that their treatment and their journey is over. And this is why this lab matters, because our work is no longer about just curing cancer. It's about curing it better and preventing these long-term problems. It's about ensuring that a child, when they survive cancer, that they really are able to truly live the rest of their life. That is the responsibility that we carry forward as clinicians, as scientists, as donors, and as partners. Now, I've had the privilege and occasionally the healthy challenge of working alongside Dr. Cairo for more than 25 years. And over that time, we've built a strong partnership grounded in mutual respect, a shared passion for our patients, and probably a good dose of sarcasm, which I know he would expect from me today. But what has never wavered is his relentless commitment to innovation and pushing the science forward. So there is no better person to speak about the advances born from the collaboration of Children's Cancer Fund and NYMC, who guides this extraordinary team of research scientists, physicians, nurses, and many others working together on the front lines than Dr. Cairo. So please join me in welcoming Dr. Cairo.
Thank you very much. Dr. Halperin, thank you for your very thoughtful comments. I'm always impressed when you speak and always learn something new historically. We have a bit of bond over that as I was a history major as an undergrad. And Karen, it's hard to sum up what Karen's done. I mean, you're seeing only a small piece of her this afternoon, but she's also happily married, 3 children, and is literally our nursing director of her whole cancer and blood disease center. So Karen, thank you so much for the extra work you do as the president of CCF. So, before I sort of give my prepared comments, I do want to give a shout out to our general counsel, Nick Janica, who's sitting here to my right. Nick was just so brilliant and provided such important services when CCF was at a low point about 6 or 7 years ago and was potentially going to dissolve. And we had a new leadership that came in to CCF, and Nick spent hours helping CCF get back on the feet. So I want to sort of piggyback on the comments, not that they were planned, of Dr. Halperin and Karen, and focus on the work we're doing with the theme that were already set out, which I was not prepared to hear what their themes were, but they're coincide with mine, which is a call to action and to develop therapies that are going to be gentle and curative and more humanistic, in my opinion. And that's really where our program's been. I came here 15 years and 34 days ago, not that you are counting. And the day I came on February 1st was a NIH grant deadline that particular year. And the day I arrived, I submitted an R01 purposely on that day when I arrived. And we got that R01 and we've hit the ground running ever since. And as you'll hear towards the end, it obviously takes a village. So my comments today are not reflecting my personal work, but the work of the village, many of whom are in the audience today, and some who are on the Zoom. We currently have close to over $20 million of grant funding here that sits at New York Medical College. But the Children's Cancer Fund over the years not only has been able to allow us to fund certain projects that's sort of within the guidelines of the grant that was reviewed by them, but really provide us the continuity and to leverage us to be able to do the preliminary studies that we need to get what we call return on investment, that we can then take what we've learned through the CCF support to leverage that to get even larger grants from other organizations. I want to try to reflect that. And I want to talk about sort of 4 areas among many, and so I'll try to keep my comments brief. So one of the more exciting areas that we developed proprietary in our group is the idea of finding cells that can fight lethal infections. So to give you a quick primer on this, children, but also adults, when they get treated for their diseases, whether it's a bone marrow transplant, as you heard, or they had a solid organ transplant, or if they're unlucky and develop a primary immune deficiency disease, they don't have the normal immune system to fight what infections our bodies normally fight. And the mortality in this group of patients who have failed all traditional therapies, antiviral medications, antibody therapy, and others, is upwards to 90%. It's a fatal disease. I want to talk about 2 of those fatal diseases. One is called cytomegalic virus and one is called adenovirus. Most of us can handle these infections if we're exposed to them because our immune systems function normally. We have immune cells that have been exposed to these viruses before, and they're ready to fight back when they're exposed to these viruses again. That's how vaccines work, right? You get a vaccine, you develop an immune response to that. There's a memory immune response. We developed a method where we could take a family donor, most of the time a parent who's only half matched to their child, and find a way of enriching these memory T cells, extracting them, which we did in partnership with our cellular and tissue engineering laboratory at Westchester Medical Center, and then give these memory T cells back. We call them viral specific cytotoxic T lymphocytes, or we'll call them CTLs. We developed this idea. We went and got an R01 grant to fund it. We developed a 10-center consortium around the country with some of the best centers in the country: Children's Hospital of Philadelphia, Johns Hopkins, UC San Francisco, Children's Hospital Los Angeles, various top centers. And we said, we're going to test this in patients who are refractory to their infection and are about to die of this disease. And the result of this, I'm proud to say, we didn't think this was going to be as good as we originally thought, is that we've now treated 20 patients with the CMV cells and 20 patients with the adeno cells, so 40 total patients. We just presented this as one of the best abstracts at the international transplant meetings a couple of weeks ago in Salt Lake City. And what we found is that we can induce 85% of these patients to go into a complete response, where we completely eradicate the virus and we eradicate the disease that it's causing, 85%. And when we follow them out over a year, only 2.5% of the original patients ended up dying of their original viral infection. This is an incredible work, and the science behind it, which is identifying the exact what we call phenotype of the cells by very high technical methodologies like single-cell RNA-seq and mass cytometry and nanostring immunoprofiling, which is done in our laboratories here by support from CCF. This has been an incredible accomplishment, and we're about to embark on a randomized, maybe phase 3 trial to compare this to standard of care to really prove that this is curative therapy. So the second one I want to talk about is also something that CCF has been involved with. And this resulted from a National Cancer Institute grant that we got. We were one of the 2 centers in the country that got what was called the Cancer Moonshot grant that came out of the Obama administration. And they funded a program for pediatric immunotherapy, and 2 centers were selected to get what was called a U5 for. We were one, and another one was a consortium with Children's Hospital, Philadelphia, and Stanford. This grant, over about a 6-year period, was focused on developing immunotherapies for children with solid tumors, the one that Dr. Halperin just mentioned, with the idea that we can develop new forms of immunotherapy, which could include cell therapy and other forms, to not only cure the one patient that Dr. Halperin showed, but to potentially bring this concept to the clinic and treat either difficult patients at diagnosis, or more importantly, ultimately reduce their exposure to chemotherapy and radiation. Through this grant, we identified a number of mechanisms of resistance to forms of immunotherapy. More importantly, we developed and identified a number of targets on these cancer cells. And these targets are exploitable, because when we use the word target, we mean that the target is present on the cancer cell, but not really present on any normal human cells. So we can exploit that by just going after the cancer cell and not going after normal healthy cells, which of course is going to be good for the patient because they won't get exposed to other forms of toxicity. So through this pilot data then, and CCF joining forces with the largest pediatric cancer foundation in the country, called the St. Baldrick's Foundation, if you're familiar with it, they provided us a grant, and we're hoping that by the end of this year, we'll actually be in a clinical trial. And we have built what's called a chimeric antigen receptor, which is a name of where we insert genetic material into an immune cell. In this case, it's a natural killer cell that will express a binding site on that cell to bind to that target on the cancer cell. chimeric antigen receptor. This will be on the quiz, so please. And so we have just finished over the last 2 years all the preclinical work, and we're in getting close to manufacturing what we call GMP grade MCAM, CAR, and K cells. And some of the workers, and certainly looking at Hong Wen over there in the back, has done a lion's share of this work. Where we'll be taking this to the clinic as a first in man study for a sarcoma called osteogenic sarcoma. And this is going to be the first time this has been done in patients with this very common, hard to treat bone cancer. Patients who get osteogenic sarcoma who relapse have at best a 5% chance of being alive a year after the time that they relapse. So this translational work would not have come about without CCF partnering in a bigger way, leveraging what they do with a larger organization to get us to the point where we bring this to the clinic. Third area I want to talk about, near and dear to me, and Karen teed it up for me about lymphoma, is that we have been a center of excellence, I hate to say, but true, for lymphoma for a long time here. And I want to talk about a couple of things there. So CCF directly is supporting us to develop targeted therapy for children both with Hodgkin lymphoma and adolescent young adults, and for a form of non-Hodgkin's lymphoma that she mentioned earlier, Burkitt's lymphoma. So what we're doing here is the same as what I said earlier. We're trying to exploit targets that are on these lymphoma cells that don't necessarily exist on other cells, and to use an immunotherapy approach to reduce their exposure to chemotherapy and literally eliminate radiation therapy. So we'll start out with the Hodgkin's piece. So we have exploited 3 targets in Hodgkin's lymphoma. One is a protein called CD30, which is present on all the Hodgkin's lymphoma cells. One is something we call a checkpoint blocker called PD-L1, which is also present on 100% of Hodgkin cells. This protein, when it's expressed, puts out a break signal to our normal immune cells and says, you cannot attack me. This is a key protein that was discovered 15 years ago that says our immune system why it's not doing the job. So getting back to Dr. Halperin, why did this happen? Well, because the tumors are very smart and they express signals so that our immune system look the other way, because part of the thing that our immune system is supposed to do is to attack transformed cancer cells, but it fails to do that. And a number of times it's because it's seen a signal says, stop, red light, can't go forward. So we want to exploit that. And part of the Hodgkin's environment of cells is a bunch of regulatory cells, and we want to shut those down. So over the last almost 14 years now, Dr. Hochberger and I have been running a series of trials where we're using now 3 agents to target immunotherapy. And 55 patients later, we still have 100% survival. And sorry to say this in front of Dr. Halperin, none of them are getting radiation therapy. So I'm sorry that this is an affect your long-term livelihood, but you did key up to it in your comments earlier. But we're not done there yet. I want this part finished with, there's still patients not responding. And we want to find a way of still treating this with cellular therapy, not just protein-based immunotherapy. So we took one of these targets, CD30, and in partnership with one of my collaborators at University of North Carolina, the other Carolina institution besides Duke, where Dr. Halperin was the chair of radiation oncology. And we've now developed a chimeric antigen receptor against CD30, but this time it's in a T cell, not an NK cell. And we now have an open protocol, first in child, first in adolescent, first in young adult, of giving patients' own cells, these CD30 CAR T cells that we would manufacture from their own immune cells, and to give them in patients who relapse after their standard treatment for Hodgkin's. All of this, remember the seed that CCF is creating here by supporting the clinical trials, is going to result, with fingers crossed, in a PPG grant that we're submitting with multiple centers, including our partner at Sloan Kettering, May, if God is willing to get it done by then, a large program project grant to look at developing next generation immune cells to treat all kinds of children, adolescents, and adults with lymphoma. The last piece I want to talk about is acute myeloid leukemia. This is a disease that's also a devastating disease, not just in children, but also in adults. Our cure rate in children is probably 70%, somewhere in that range. A lot of the patients require a lot of therapy. A lot of them require bone marrow transplant. And a lot of them ultimately relapse and don't survive. And we've had patients who've been connected with CCF who have suffered that fate. So through a lot of seed support we've gotten from CCF over the years, our laboratory, some of whom are in the audience, Morgan and Youngling in particular are here, we have gotten 2 successive Department of Defense grants called TTSAs, which is a team science award that we do when we collaborate with other institutions, and have partnered in developing methods to overcome the problems that we see in acute myeloid leukemia, and to develop cellular therapies that are going to be more beneficial to them. I'll start with the clinical, and then I'll end with the more basic science. So through these grants that we've gotten from DoD, we just completed a trial. We treated 10% of the patients on this trial here, of taking patients who have very high-risk AML. In fact, if I'm right, the red carpet today was one of those patients. By the way, I wasn't invited to the red carpet, so thank you very much. Exchange a little sarcasm with my sister here. So she was a recipient, in fact, the last patient registered on this trial, if I remember. So in this trial, what we did is we took parents as donors, and we took extra blood for the transplant. We took extra blood from the parent, and through a proprietary method that we've been working on and our colleagues at Nationwide Children's, expanded these cells into a lot of what we call natural killer cells. And then we give these natural killer cells after the transplant to prevent them from relapsing. Because even if we do the transplant, there's a 40% chance that they're going to relapse anyway after that. Just completed that trial. The science is still ongoing. Good to tell you that the 3 patients we've treated so far, knock on wood, are doing well and in remission. But it's not enough. So through this Department of Defense grant that we got, we and our partners at Nationwide Children took it a step further. And the step further is that a protein that's expressed on every AML cell is called CD33. There's medications out there to treat that. There's an antibody directed against CD33. We took that idea and we developed a chimeric antigen receptor for CD33 in a natural killer cell. We found a unique way of doing this by basically knocking out the gene for a protein called CD38. Long story, but basically if CD38's there, the natural killer cells might kill each other. We call that fratricide. That won't be on the quiz. And inserting the CD33 chimeric antigen receptor using an adenovirus into that very locus. And I'm happy to tell you now that we are going to be one of 6 centers that are going to be conducting this phase 1B, phase 2 trial of giving donor-derived CD30 CAR NK cells to children, adolescents, and young adults with refractory AML. And the final piece of it is that our lab is going a step further. We believe that there are other novel targets in AML. In particular, we have identified a target called IL-1RAP that our group, and also one of our fellows, Shaima, who's here, is also working on the project. And another one called CD123. And so we are actually assuming that this will be good, but not perfect. We are looking at ways of developing other CAR NK cells, looking at these targets, but actually trying to basically manipulate the NK cell so it'll work better, which is, in scientific terms, is what we call base editing. We want to base edit out the things that make the NK cells work better, and we also want to base edit out of why they might not be working better. So this is ongoing work, and we're seeking additional grant support to complete this project. But the whole idea of what I'm trying to say is what Dr. Halperin and Karen said, that we have a mission. It's a call for action, and we are very proud of the success. When Dr. Halperin and I were starting, and as he said, some people asked him, how do you get up in the morning and do what you do? Because we were facing cure rates in our days when we started at 20–30% of children with cancer. This was devastating. A lot of them, we were just providing comfort care, palliative care. But we each independently had a vision. And that vision is not only can we get that cure rate up, but we can find ways of curing these patients and helping these families in a gentle and more humanitarian way so they go on and live their 90-year lifespan, hopefully longer in time, without late effects, without being in the hospital all the time. That's what this program's about. That's what CCF is about. So again, thank you very much for all the donors, and particularly my team that's here. I'm a lucky guy every day. Of course, as Karen mentioned, I'm a lucky guy because 55 years and how many days now? 3 weeks since our first date Ellen and I had. And I particularly want to thank New York Medical College. From my heart, from the day I got here, it's been a marriage in heaven. Been lucky. Dr. Halperin's been the chancellor almost all this time. Dr. Schluger now the new dean. They've been a partner, as Karen said, and I hope for a long-term partnership. Thank you so much.
1, 2, 3.